Today, we're jumping into a really fantastic story. It's all about how some pretty abstract math concepts are actually being used to tackle some of the biggest, most complex challenges we face as a planet.
I mean, just look at this question. It's a huge one, right? This isn't just a thought experiment. It comes straight from the United Nations Sustainable Development Goals, Goal 11 to be exact. And with our world's population climbing every single day, we need smart, sustainable cities, and frankly, we need them now.
So when you think about who's solving this, you probably picture architects in high-tech offices, right? But what if the blueprint for these amazing future cities wasn't being drafted there at all? What if it started in an 8th grade math class? I know, it sounds a little out there, but stick with me because that's exactly what's happening.
And that brings us perfectly to our first section, a surprising design challenge. We're going to see how this wild idea goes from a simple classroom assignment straight to the drawing board.
So here's the setup. 8th grade students at a place called Kingdom Schools were given this incredible task. They had to stop being just students and start acting like professional urban planning consultants. Their mission? To design, justify, and then build a model for a brand new, totally sustainable city for Saudi Arabia.
And you know, this wasn't just some abstract project with no real-world connection. No way. This project is directly plugged into Saudi Vision 2030, which is this huge, ambitious national plan to build modern, forward-thinking cities. So these students were engaging with a real national vision. Talk about real-world learning.
Okay, so how in the world do you even begin to build a city using just math? Well, that leads us right into our second section, the geometric toolkit. Let's break down the 4 essential math tools these students used to build their own metropolis.
First up, we have translation. Honestly, it's super simple. All it means is sliding a shape from one spot to another without changing its size or even turning it. Think of it as the ultimate copy and paste tool for a city planner. It sounds basic, but trust me, it is seriously powerful. And here's where that simple idea gets really interesting. Imagine you design one perfect, sustainable city block. Using translation, you can just copy and paste it again and again. And just like that, you've created entire neighborhoods that are easy to get around and perfectly organized. That simple slide suddenly becomes a tool for building a city that can grow. Next up in the toolkit, reflection. This one is all about creating a perfect mirror image of a shape across a line. In the world of design, this is what gives you that satisfying sense of balance and symmetry. Now this is where math gets a social conscience. By using reflection, students had to think about fairness. Let's say you build a great park on one side of a big highway. Well, what about the people on the other side? By reflecting that park design across the highway, you make sure both communities get equal access. That's geometry being used to build a more equitable world. All right, our third tool is rotation. It's pretty much exactly what it sounds like. You pick a single point and you turn a shape around it, kind of like the hands of a clock. The shape itself doesn't change, just the direction it's facing. So why does this matter for a city planner? Well, rotating a building by just a few degrees could be the difference in catching enough sunlight to lower electricity costs, or catching the wind just right for natural ventilation. All of a sudden, a simple rotation becomes a key tool for sustainable, energy-efficient design. And finally, we have dilation. The easiest way to think about this one is as the zoom-in, zoom-out function of geometry. It lets you resize a shape, making it bigger or smaller, but, and this is key, it keeps all the proportions exactly the same. This tool is absolutely essential for planning for the future. You know cities are going to grow, right? Well, dilation lets you take a successful neighborhood design with its perfect ratio of green space to housing and just scale it up as the population expands. It's how you plan for growth without creating a mess. So, we have our 4 tools: slide, flip, turn, and zoom. Now for the really cool part, which brings us to section 3, from math to metropolis. Because the real magic happens when you stop using these tools one by one and start putting them all together. They use something called a composed transformation. Just imagine taking a housing block, translating it over here, then rotating it a little bit, and then reflecting it across a central park. It's this layering of simple actions that lets you create the complex, intricate, and really functional patterns you see in a real city. Okay, so after all this theory and all this math, what did the students actually create? Let's jump to our next section, building a sustainable future, and take a look at their final projects. And this was no small task. I mean, look at what they had to deliver: a physical 3D model of their city,
a detailed coordinate map proving all the math. They even designed a unique logo for their own pretend consulting firm using transformations. And on top of all that, they had to write a full justification and give a final presentation. This was the whole shebang.
Which brings us to our final section and really the most important point, the real-world impact. Because this project was about so much more than just getting an A in math. Its true value was in all the other skills they were learning along the way.
Just look at this list. The project was built to teach communication, design, problem-solving, and teamwork. These aren't just nice-to-have skills. These are the absolute essentials for success in pretty much any field you can think of.
And check this out. This shows how they were actually graded. To get a top score, it wasn't enough to just do the math right. You had to analyze problems, strategically use all 4 transformations, and link your choices back to that global sustainability goal. And you had to be a great teammate. That's way more than a math test. It's a test of real-world skills.
And so we come full circle, right back to the question that drove this entire project. It wasn't never, what is a translation? It was, how can we use translation to build a better world? That little shift in framing, well, it changes everything.
And that leaves us with a pretty inspiring final thought, doesn't it? If this is what a bunch of 8th graders can achieve with basic geometry, what unique tools do each of us have? And how can we start using them right now to design the future we all want to live in?